Hello everyone and welcome. Today I'm going to tell you about rusty hardware in the loop setup that I have been exploring. This is part two of my talks this year, but I'm going to tell you about part one in a bit. So first, I would like to say very much thank you to the whole Espressive teams. It's not the first time we've been working together, and it's a pleasure, and I'm very honored to be talking about this topic in front of you. Now, I have a small agenda for today. Just an overview of what we're going to talk about. First, I'm going to tell you who am I and why I'm speaking in front of you about this topic. Then I'm going to share about what we're building at the AeroRust community and what actually AeroRust is. And of course, the most time we will spend on tooling, how you can actually build such a setup with the current existing tools in the Rust ecosystem. And of course, I'm going to show you how you can remotely flash. Yay! Small demo, but still very applicable to many of our work. And at the end, we're going to talk about generally conclusion, where the ecosystem is, and so on. So the first thing you should know about me is that you definitely need to come and speak with me if you want to build a spaceship. I'm very into aerospace, and I actually started in 2020 because I usually love a challenge, and the aerospace industry provides a lot of challenges, different challenges, extreme environments, very tough regulation, and so on. And I really enjoyed that part of it. And I think this is the future just going forward. On most platforms, my name is Lachezar Lechev, but on most platforms, you can find me as LPL, except on X, where I'm with _. If you want to say hi or you want to discuss something, just direct message me or, join in the Discord server that I'm going to share in a bit. Okay, apart from that, I started my own company in a sense of having like a small space for development. And of course, when you are talking about the business, you do have a few disciplines you have to handle. First, you have the technical stuff, of course. As developers or hardware people, we would like to solve an issue, whether it's useful for anyone else. They can decide. But if we find a niche, something that we need, and we can build it, then usually that's enough for us, right? Apart from that, though, you still need to have some kind of a business model, how you're actually going to make money out of it. And of course, apart from the business model and the technical solutions and so on, you do have resources. So resources can be anything from equipment or people and so on. Of course, you have to be sustainable as a business. So you have to find a way to keep doing what you're doing without breaking the bank or without being on the street, basically. Because you don't make money out of it. And as you can see here, like I added this screenshot from my from the sponsorship account in GitHub. But you can see that for 2.5 years, I haven't received a single sponsorship, although I have been contributing to many projects, especially in the embedded world. And this just showcases how challenging this sponsorship kind of a way to sustain your open source work is actually is. And finally, of course, you have to when you're building a product, whether this is a software or a hardware product, you have to define some kind of a scope, right? You can still start working 5 years, 10 years on a single project without validating it, without defining what the people actually want, and hope for the best that when you release it it's going to be very profitable or very used. But that's not usually how we do things, right? We want to start with something small and implement that to validate it. And of course, income, as I said, you have to provide for your family or for yourself. So it's very important to handle that. Apart from these disciplines, when we're talking about aerospace, of course, the technical disciplines or um, the science part of it is very important. And in aerospace, what you find out is that you basically have all the disciplines you can have, right? From biology to mathematics. And of course, when we're talking about mathematics, it basically comes to everything related to physics, or even like how do you control a given satellite, how do you orientate specifically to Earth, and so on and so forth. So this slide is just more to give you a sense of the vastness of the aerospace industry, because of course in mathematics you can do simulations, you can do fluid dynamics, you can apply mathematics or dynamics on your flying thing, whether it's a rocket or a drone. It really doesn't matter, but mathematics is in the core of things. But then you have all the other things like physics and chemistry and biology. And just again, for a few examples that you can look at, of course, material science, when you're picking, for example, what material to use on your rockets or for a given pressure vessel or whatever, you have to know what the properties are, how the structure will react, and so on. And of course, you have guidance, navigation, and control, having different frames of references for your, let's say, drone or your satellite or your space probe. And you have to convert different things or different coordinate systems, different frames to each other, and so on. So these are just a few examples that I wanted to give you, just to get the sense that in aerospace you cannot know everything. You can partially do everything and know a bit of everything, but you need a big team for handling that. So it's very capital intensive to do this kind of projects. And apart from the company part, I'm also the community manager of the AeroRust community. This is the Rust community for aerospace applications. I decided to just share the website because you'll find what you need there. We do have a small blog, and also we are planning to release more content, including a newsletter where you'll find, for example, resources shared by some of our members on Discord. And of course, the Discord invite, where most of our communication, or this is our place to gather and discuss all topics related to aerospace or Rust. We also do casual meetups every 2 weeks, where we just come together. We usually have some agenda, some topics that someone wants to share about, but it's a casual meetup. So the idea is just bring the people together and talk about Rust, aerospace, or anything in between. Now, the project I'm going to share with you, it started in 2023 as a workshop, an AeroRust workshop at Space Conference Plovdiv. I'm very grateful again to Espressive that they provided some parts of the whole kit that we could use as hardware. And you can see on the right people like assembling the frame, but also on the bottom right, the whole assembled workshop kit. And also on the left side, you can see all the components that we had. And we really wanted to take this to the next level. So that's why we started working on a workshop with a product, like a nano satellite product. But you can find more about this project in part 1 of this talk, which happened on the UA Rust conference in 2024. They should release the video soon, or they have already released them. So definitely check the YouTube channel for that. But you'll find more detailed information about the project itself. And okay, so other than that, what generally what we're speaking about, we wanted to give people this workshop to get started with embedded Rust specifically. So instead of building like actual nano satellites, we decided, okay, let's take this nano satellite, still call it a nano satellite because eventually we want to get to space, but let's give people something tangible, so something that they can build as a whole application and also do experiments with it. So what we have decided so far is to focus on these helium balloons. On the right, you'll see that this is a latex balloon. It's usually used for meteorology as well. And you can strap one of these kits and send it to the stratosphere. And of course, there are different sizes of balloons. But at some point, they pop, and you have to go and retrieve your hardware. And on the bottom, that's actually very interesting. NASA launches maybe around 50 of these balloons every year. These are called super pressure balloons, and they can stay up in the stratosphere for months at a time. Apart from the helium part, of course, that's the experimental and how you can develop the project for something useful. We focused on using async or embassy, and it gave us a really nice overview of how you can use asynchronous simply, but also in a full project, basically in a whole project. And of course, the workshop is open source. The current workshop is still in progress, so we're still working on it. There are some exercises for the older version, but now we did some changes. So stay tuned to know more about the latest state. Okay. With that out of the way, what do I want to build, or what was my goal as a setup when I started working on this presentation and this talk? Well, I'm lazy. And frankly, when I was working on this project and constantly moving all the hardware with me, it gets tedious to constantly set it up. I also have cats with my wife, and they can chew on the cables and so on. So it's not really good to carry it all the time with you. And this is sort of the setup I wanted to build. You have this local network. Let's say it could be Wi-Fi. This is the bottom part, of the picture. But you can have some kind of a local network, either Wi-Fi, and you can get the hardware with you and plug it in. But what I would like to have is being able to remotely flash a device through the internet. And in this case, we're going to see how you can use VPN. To do that, of course, to have a private network for that. And in this case, I used Raspberry Pi 3, which I had laying around. It's not very powerful, but still for flashing and getting result, that's enough. And you can see that you not only have the debug probe connected to the hardware, and I'm pointing there because the hardware is there. I'm going to show it in a second. But you do have the debug probe connections. So it could be a single board that you use or multiple ones. And again, your boards can also communicate via USB, for example, or Ethernet. It could be sending packets over USB to communicate with, let's say, another computer. So we have to take this into account when we're not only flashing, but we want to have some kind of a feedback. And this is the general idea I wanted to have. Now, how do we get there? That's the question. Well, we have to talk about the tools. And this is just a simple overview of the tools that you can currently use. First, of course, you have ProbeRS. We do have ESP flash as well, which you can use on Espressif chips. But ProbeRS also supports Espressif, as far as I know, and it's usually the go-to tool for flashing your devices. Then we have Teleprobe, where we're going to speak about more in details in a bit. And the general notion of this tool was to hack on it, because it's meant for a specific use case, and I'm going to share about that in a bit. I personally use NetBird for the private VPN. And of course, we have this Packet Explorer tool, which I started developing probably 2 years ago, to have a way to explore all the packages that are coming either from the networking or USB, and sort of concise way. But I'm going to share about it in more details in a bit. Okay, so ProbeRS, well, it's easily enough to go to the website and see how you can install it. It's very important to set your UDEF rules, especially in on Linux at least, and you're good to go to flash and even debug. Now for Teleprobe, and this is the most important part, Teleprobe is specifically made for a single use case and for a specific project, and that's the embassy project. It's made so that it can run continuous integration tests with hardware in the loop, basically. And as you can see here, this maintenance status can be found on the README. So we cannot expect this tool to change for our needs or my needs. So we have to figure out, what's the next step in the ecosystem to provide this tool. And you can find the Teleprobe tool in the embassy organization. Now, when I started with Teleprobe and I started, doing some of the preparations, I stumbled upon a few issues. First of all, it's a very simple and stupid mistake, but it's actually in ProbeRS. The serialization and the serialization of this structure were different. So as you can see here, we have try from. So it will try to create this structure from string, but serializing it actually gives you an object, a JSON object. So this meant that when I tried to list the probes remotely, it was giving me an error, a vague error that I had to figure out and debug and fix. This is easily fixed, right? That's not a big issue. The other problem was that for some reason, when the verification for the flashing on ProbeRS is enabled, probably it's related to Teleprobe, but it starts failing. So for the time being, I just disabled it, and that's probably one of the reasons why the workshop onboard computer firmware isn't working. It's a bigger application than just a simple example from Embassy. So there might be something going on there. So I haven't dig deeper into that to actually fix it, which probably should happen at some point. And the last problem I wanted to share is that, it doesn't work on Espressif chips, at least for now. There was an open PR, but it got closed. As you saw, the maintenance status of the project was specifically to handle the embassy project needs. So the maintainer decided that this is out of scope, and it's perfectly fine. I think most people have to decide what they want to work on. Otherwise, you get spread out and you don't finish anything. Okay, so we do have Teleprobe working, sort of. Then we need the private network. And this is where NetBird comes into play. Underneath, it's using WireGuard, but it gives you a few features on top of it. It's open source, and also if you want to self-host it, you don't need to use their platform. You can self-host it and still get these features that you want. I think for small projects, at least for my needs and the things that I currently do, it's enough. At some point, it might not be enough, but for the time being, it's enough. So if you want to build a VPN and actually work this way, definitely check it out. And the last but not least, I want to share about this tool I've been working on. At least my understanding, when you start working on a project and you get some data, you want to debug it, or you just want to log the data somehow out of the embedded platform, you want to build some kind of a CLI. And this Packet Explorer is meant to be a crate that you can use to build your CLI for your embedded project and make it easy. Because oftentimes, of course, when we're talking about network listeners, you have UDP currently implemented, but you have other layers, you have other protocols as well, and these are things that I want to add. But what it's important to know is that every project is different, and even every medium is different. So if your embedded project sends one kind of a data type or serialized data over UDP, let's say JSON, it might not send JSON when you're talking about serial communication over USB. So you have to be flexible in how you define these, the serialization and serialization, so that when you receive the data, for example, on your laptop or on the CI or whatever, you can actually perform the deserialization and also do something with the data, or just record it, log it to some data and so on. So this is very important. And I mentioned USB, of course, there's serial, and also I want to add USB to it. So the USB protocol, the ACM, the CDC ACM. Also, I mentioned data logging. I haven't decided how, but for now, just files are enough. And again, many features. Most importantly, again, to bridge the gap between, let's say, the current communities, especially the Arduino ones, and what we have in the Rust ecosystem, we have to of course provide tools for plotting as well. And one of the most known tool in the Arduino community actually comes from the Arduino IDE, where you have this Arduino serial plotter. And apart from the plotting part, I decided to work on the so-called forwarders, which can take the data we are receiving on a specific channel and then forward it to the Arduino serial plotter. This is nice because it bridges the gap if someone wants to come from the Arduino world and C and writing C and join the Rust community and figure out how to do embedded there. Having a tool which is not only useful but also familiar is very important, and I think more people will enjoy coming to Rust if they have these tools. Okay, so with that out of the way, it's time to show you the demo. Now, initially, I wanted to flash the onboard computer with the firmware that we have for it. Again, stripped down version because we don't need all the sensors and so on. But sadly, teleprobe didn't work. So we have to use just the Embassy ADC example in this case. Okay, so first let me just show you what I have here. This is the hardware. You see this is the prototype that we're working on. This is the Raspberry Pi, and the debug probe is connected to it, but also I'm powering the Pico here, the Raspberry Pi Pico in this case. Okay, so what we're going to see again, just for completeness, we're going to see the part where the laptop called Kracho here sends the firmware over the internet through the VPN, through the virtual private network, to the Raspberry Pi, and the Raspberry Pi actually flashes the hardware. Now, I'm going to say out of the bat right now that it's going to give an error, and that's specifically because, as I said, teleprobe is made to run for continuous integration stuff. So it expects the test to run and exit at some point, otherwise it will time out. So in this case, we're running a continuous infinite loop, basically. So after the timeout runs out, then we get an error. But you can still continue flashing the device if you want to. Again, this is only the part with the debug probe. We still don't have the Ethernet and USB part working, but that's for the next time. Okay, so very simply, I do have the Raspberry Pi here opened, and I have the CLI actually built for the Raspberry Pi. And we just call serve. There is a configuration file on the Raspberry Pi which defines a token. You can define other ways to authenticate as well, but also it defines all the debug probes that you have connected or can be connected to your device. Now that we have the server running, I have prepared the setup, the teleprobe command that will actually flash the ADC example of Embassy. And what you can notice here is that here we do have some Rust log improvements just to clear out some of the stuff that we don't need. But what's mostly important is this cargo teleprobe client. And in this case, we just use this token. We don't use any fancy authentication method. And we define this host, which is in the private network. And of course, we say run, and we say which target. This is the debug probe we have defined in the configuration. And last but not least, the L file, in this case, the release build. And if we run it, we see that it's flashing. We're not going to see logs again because of this. That Embassy requires the response and not continuously running the test. And as you can see here, we got around 8 seconds of logs until the deadline was exceeded. This is again in the configuration file, but you can tweak it if for your needs, if you need it. And you can see the logs from the device itself. In this case, the ADC values are from the 3 pins, but also the temperature, the internal temperature sensor. And if we go back to the client side, eventually after the request has finished, you can see still the log from the server, but also the log from the device. So we still get, in this case from DFMT, we still get the DFMT logs. And that's really nice if you want to debug it remotely. This was a simple example and demo that I wanted to showcase, at least how far I got working on it. But when we're talking about again these new tools or these limited tools, we have to of course talk about what can be done more. And teleprobe and this experiment that I did, with the demo and working on the tool itself, it was a fun little experiment. But as I said, it's only for a single use case and handles a specific project. It won't accept any features that are out of scope. And we're still missing quite a few tools that can be added. For example, staging. I know a company working in the nanosatellite business, or actually already satellites business, that before sending the commands to the actual satellite, they have a duplicate hardware on the ground staying in a rack, which can execute all the commands that they send and also validate that the hardware and the firmware will do what they actually expect it to do. Of course, that means that you somehow need to inject simulated sensory data. And last but not least, as we saw, you have to have some kind of a monitoring system that it does what it does, or it reacts as it should react, or that every data point that you get from the monitoring is okay. And if somebody is interested to discuss this Packet Explorer tool, which is specifically for the monitoring part, I'm open either in this conference or after the conference. You can just come and talk to me. I'm very open, and I try to find some use cases to implement to make it a better tool. And with that, I would like to thank you about your time, and hopefully you have some questions about me. And last but not least, you can find the slides on this URL or the QR code. Thank you.